Hello. Usually I try to make these videos as I go along, but this rocket turned out to be kind of a rush job, and it did actually fly. So decided to kind of go back and put together some things that hopefully will help if you decide to make a gingerbread rocket. So right off the bat, my goals, first to make it safe. So I put big fins on it. I did an open rocket simulation that I'll show you in a few minutes. And then I wanted to make it mostly gingerbread too. I didn't, this was for a Christmas launch, just kind of a fun challenge to do something different. I didn't really want to just skin a regular rocket with a thin coat of gingerbread or icing or something like that. So I'll show you some of the trade-offs I made there. But in order to also keep it safe, it still has non-gingerbread components like the motor mounts and recovery components and things like that, the launch lugs. There's no way that I can imagine that you could make those strong enough that it would be safe to fly. And then the final thing was kind of a matter of pride. I wanted it to taste good. So maybe you don't want to eat a rocket that's launched and been in the dirt and has ejection charges, etc. in it. But one benefit is it's easy to eat the scraps, and you'll end up with a ton of scraps from this. I did not use, if you look on some of the gingerbread forums, there's some recipes out for something that are construction grade gingerbread, so it meets like a contest rule of being edible, but people say it's not very tasty. The main difference I think with those are they leave out the leavening and sometimes use shortening instead of butter. So I found after a couple poking around in experiments, this is really kind of a ginger snap dough that I used, and it has a touch of white pepper in it that gives it a good flavor. So that's what I ended up using. So it's got leavening in it. It's not super airy, but it seemed to turn out pretty well. One of the first things that I figured out is I certainly don't have the skills to be able to make a tube. So I tried gingerbread, again, looking at a lot of the gingerbread forums online. One of the ways that people have had success doing it for like castles and things like that have rounded components is to bake the dough and then roll it over a mandrel of some form. So I tried that with gingerbread, didn't work. You can see some of my failures here that ended up in a snack jar. Another thing I did as an aside, and I think this is something I'll probably look at if I ever decide to do this again, I tried some waffle dough, right, from a waffle cone like you use for an ice cream maker. And that was, it turned out actually pretty tasty, and it's lighter, both in terms of taste and in terms of actual weight. So that might be promising, not to do a gingerbread rocket, but something that's an edible rocket with waffle dough. So not being able to make a tube, then I decided, well, I'm just going to have to use flat components. So here's the picture of the cardboard that I cut out to use it. So the first piece up here, this is the side panel, just to form sort of a rectangular tube. This is the sides of the nose cone, and then the fins itself. So these are really the gingerbread pieces. There were 4 copies of each of them that I made, and the way that I ended up doing it was that I baked the gingerbread. I rolled out the gingerbread, and I'll show you in just a second how I used a little bit of a collar to roll it out. 4 millimeters thick. I rolled it out on Silpat, that silicon mat. I was going to try to use parchment paper, but it doesn't stay still enough for you to roll it out well, and it's really important to try to get a good sheet of the dough. And I cooked it on a preheated like pizza stone at 350 for 8 minutes, and then I pulled it out and kind of it's going pretty quickly, but not super bad. Used these patterns to cut the dough, right? Because after that point it had already risen a little bit, and so that was kind of the methodology, again based on some of the lots of online help from the gingerbread house forums, and so then I put it back in. So I baked it for another 4 to 5 minutes based on how dark it was getting. So again, I 350 oven, preheated the stone, rolled it out on Silpat, then cut out the pieces and then finished baking it, and then let it cool on a regular cooling sheet. So that was how I ended up making the gingerbread itself. And then the kind of other pieces, the non-gingerbread pieces, they're out there on Tinkercad. This is public, so you can go use it if you want. And kind of let me walk through them real quickly. This is the bottom, and so I had a 42 millimeter body tube in here. It was really just a piece of scrap tubing I had. It was 23 millimeter or 23 centimeters tall, and so this is the bottom. And this is sort of an alignment guide. I thought I could be smart and kind of tuck the dough in, once it was baked, and hold it better. It didn't really work. For one thing, the dough almost doubled in size, but it did. I might just make these flat in the future, but it did help to have them there, especially for the fins on the corners here, and in the launch lug, so to be really secure. The top part is really just a mirror of that. Without the fin locations. This is the base of the nose cone, and so each of the triangle pieces go on it there, and then this is the nose cone shoulder. So you can't see it here, but there's a little ring in here. These two are glued together. I'd like to do this as one piece, but I couldn't figure out how to print it as one piece. And the shot cord mount you can't see either is in here. This is what I kind of mentioned a second ago. This is a collar that goes on a PVC pipe. So it holds it up by 4 millimeters. And so what I did was I put 2 of these on a piece of PVC pipe. You could adjust the width to whatever made sense for the part you were trying to roll out, and then use that just like a rolling pin. Then this final piece, is the motor mount. I decided that this thing was going to be probably lucky to get one good flight out of it. So what I did was I just went ahead and decided, well, I'm just going to glue the motor in to the motor mount. So this is the bottom of the motor mount. It goes in here. These 4 holes are for M3 nylon screws. I've used these in a lot of designs in the past. They're pretty cheap. They're pretty strong. And they're lightweight, since they're nylon. And what I do is I made a hole here in the bottom piece. This goes all the way through these 4 holes, and actually I have a tap. So I tap these 3D printed holes, or tubes, I guess, and then once the motor is installed, then just put 4 screws in that to hold it in. And then the plate itself, of course, is to be able to hold the thrust. The screws keep it from blowing out on ejection charge. This is the top ring for on the motor, so again, just glued this to the motor, and this is the shot cord mount. So I just ran the shot cord through, wrapped it around the motor, wrapped it back up, tied the loop there through. So that's kind of the pieces and how things go together from a 3D printing perspective. The open rocket sim, I as usual with the designs that are new, I tried to kind of go through it iteratively, weighing each piece when I could, kind of dial in the open rocket. Certainly one thing, I don't think there's a way to do it, is this is a round rocket and not a square one. But I did some experiments with the dough and some of the gingerbread, and found that the density of the gingerbread I was making was very close to just the cardboard density that's in open rocket. So everything here, is pretty much a start with, hey, I found that the dough expanded to about 8 millimeters. So I dialed the pieces in like that, used the cardboard density for the gingerbread parts. And overall, the weight, the total weight, and the individual pieces, when I was able to measure them as I was building, came in pretty close. And that presented a big problem, right? Which is this is a heavy rocket. And so I had hoped to fly it with an E12-4. But once I looked at this in terms of the delay, it would be way too long at 4 seconds. The velocities look bad, the flight time is short. You look at the graph, and it just wouldn't be a safe flight. So maybe I wouldn't have picked this motor, but I had an F-44 left over from some of my Odd Rock stuff, and that simulated much better. The reason I probably wouldn't have picked it to begin with is that's a pretty hard kicking motor. I was afraid the whole thing's just going to crumble on the pad, but you'll see in a minute that didn't happen. So I decided to go ahead and fly it with the F-44. One thing that is different about this one is the ground hit velocity. I had simulated it with a 36-inch chute. When I was at the launch site getting ready to prep it, I just could not get the 36-inch chute bundled up with the chute protector and everything inside the body tube that was here. And so I ended up switching to a 24-inch chute. And there's some ramifications of that you'll probably see here in a minute. In terms of actually assembling the unit, one of the things that I found was super useful was this microplane. So it's something we had in our kitchen. We use it to zest lemons and limes and other spices and things like that. So it took a while, but the way it cuts away the gingerbread didn't really crack it or anything like that. And so here you can see the two side pieces, or two of the side pieces, kind of getting shaped. Here's the cutouts that I made for the launch lug. And angling the edges 45 degrees so the square would fit together. I also found that I needed to go ahead and kind of make a center groove here in each of the pieces. So it took a while to shape these. And you'll also see that I had to remove more material here where the fins are. So a lot of time. This was definitely not just a couple hour kind of build, but the microplane helped a lot. Here's sort of an assembly shot, and I'll admit to my first time cheating in this rocket was I went ahead and used hot melt glue to glue the root edge of the gingerbread to the body tube. So I felt like both in terms of time, I was running out of time. Hot melt glue obviously sets very quickly, but also really, again, kind of back to that safety thing, make sure I had a really good connection for the fins to the body tube. I also used regular Gorilla Glue to glue the plastic parts to the thing. But I was hoping to make all the attachment to the gingerbread royal icing, which is kind of the glue that you'll see that people use. But there's a picture of sort of the beginning assembly, and here I am mounting the sides on. I did crack one in half, so I repaired it there. The nice thing about gingerbread is you can kind of just glue it back together. And then I used the royal icing to fill it in, let each one dry, kind of rotated it. Goes well with coffee, so it's fun to be able to kind of nosh on it while you're going. This is the nose cone assembly. So I did a second cheat here. What I did was I put the royal icing on this edge, and then I put a blob of hot melt glue here. And put the piece on. So the hot melt glue attached it to the bottom. Again, I was just concerned that particularly at the time that the chute came out with the shot cord pulling this direction, that the whole nose cone would just separate there. If I tried to use royal icing, I have no idea if it sticks to PLA very well at all. So that was the nose cone assembly. Here's a picture of almost done. A couple points here. One is I put a lot of icing on the nose cone, and that was both decorative, but probably more importantly to give it some nose weight, to be able to make sure that I achieved some degree of stability and keeping the center of gravity ahead of the center of pressure on it. Also to make it stronger. So that seemed to work out well. I was going for, I'll admit, I was trying to make sort of like a submarine spaceship door and portal, and clearly my decorating skills are not all that great, but that's what I ended up with in terms of decorations. So now I'm going to go ahead and run the videos of the launch. One is a short that I've posted online independently. And then the second one is a pad cam shot. So I have a little camera that kind of does semi-tracking of the units from a little closer up. So I'll run those two videos and then show you the conclusion.
This is Lee Hinkle's gingerbread rocket. And I can tell you definitively it is built with gingerbread. Starting countdown, 5, 4, 3, 2, 1, launch. That was probably the gingerbread.
3, 2, 1.
right, so thanks for watching. What happened was, you saw in the video, the chute came out, the flight went well. One of the guys said, "Yeah, that flew better than we expected," so I was pretty happy with that. And when it did hit the ground again, I don't know if the 36-inch chute would have prevented this or not. It would have helped, of course. Three of the fins broke, right? So it basically pounded on the pretty hard earth there in Pueblo. And three of the fins broke off. But besides that, the rocket was pretty much intact. So hope this helps. I really hadn't found a lot of resources for building a rocket. There's tons for building gingerbread houses and rockets that are stationary. But in terms of launching one, I thought this was pretty unique. So let me know if you know of anyone who built one, or if you build one yourself. I'd be happy to hear about it.